Hello and welcome to Software Engineering Education. My name is Georg Hagel. In this video I will answer 3 questions. What does the builder pattern look like? How can you use the builder pattern? And what are the good and bad sides of the builder pattern? We will start after the intro. If you are wondering why you see an excavator, I'm afraid you'll have to wait. I'll only resolve the riddle at the end of the video. The builder pattern is a software design pattern. It was introduced by the authors known as the Gang of Four in their famous Design Patterns book. What design patterns are and how we describe them will be explained in another video. The builder pattern is a pattern in software design. It is a creational pattern. This means it helps us create objects. I quote the purpose of the pattern from the Gang of Four book. Separate the construction of a complex object from its representation, so that the same construction process can create different representations. Often, building complex objects is divided into steps. For this video, let's look at how addresses in different countries are formatted. Address blocks on letters or packages look different in every country. Here are some examples. You can see that the address information is the same, but each country uses a different order and format. This shows that addresses can have different fields and the order changes. Now let's build a program that creates these addresses using the builder pattern. First, we need a data object to store the address fields. Usually these fields come from a database. The class is called addressData. It contains gender, last name, first name, street, house number, postal code, city, region and country. Depending on the country, these pieces of information must be shown in different order on different lines. We have to combine these lines to show the full address. The builder pattern is helpful here because it lets us build the address step by step or line by line. We need a class called address. This will store the address as one formatted string using a formatted address member of type string. Here is a class diagram to show this. The address object needs to add lines one by one. So the class should have a method called addLine, which takes a string and adds it to the address. You see this method in the class diagram. Since we want to print the address, we also need a method getFormattedAddress to return the address string. Here is how the address class is implemented. There is one note. If we add a line break to every line with addLine, the last line will have an unwanted new line, so we leave it out. Remember, the builder pattern lets us create objects step by step. Here we want to build the address line by line. For this we create a parent class called addressBuilder. This parent class will be used to build different kinds of international addresses in its child classes. A simple address builder class may look like this. It holds the address data and has a connection to an address object it will build. The main methods in address builder are called buildLine1, buildLine2 up to buildLine6. We need 5 lines for English addresses, so the 6th is a buffer. These methods are not abstract, just empty for now. I'll address this later. Here is a simple address builder implementation. With this address builder, the address object will be built line by line using the build line methods. The main program, the client, should not need to know how addresses are assembled. This is why the builder pattern needs a director class called addressDirector to control the construction steps. The addressDirector receives a specific address builder and uses it to build the address. Here's how addressDirector fits into the class diagram. The addressDirector only needs one method, buildAddress. The code is simple. With this setup, we can now create country-specific addresses. For each country, there is a child class of address builder that defines how to build each line. Let's look at German address builder. You'll see that methods 5 and 6 are not needed in German addresses, so they are not implemented there. This shows it's good that the parent class implements the methods empty and not abstract. Otherwise, we'd have to create empty methods even when they are not needed. Let's look at the implementation of the methods one by one. First, the creation of the first line. It can be seen that based on the gender information, the strings Herrn or Frau are created first. Then the salutation is combined with the first name and the last name, separated by a space. This generated string is passed to the address object. The other three methods of the German address builder class are structured equivalently. Line 2 consists of street and house number. Line 3 of postal code and city. And line 4 consists of the country. You can see why addLine does not add newLine itself. Sometimes we want a new line, sometimes not. With this first country-specific builder, we can now test the program. We first create a test data object. Then we make an instance of German address builder and give it to the address director. We tell it to create an address object, and the created object is retrieved from the German address builder. For testing, the result is printed to the console. Now you can see the first address builder in action. Next, we create other variants. Take a look at the other addresses. If you compare them with the formatting of the German address, you see that some lines are the same for different countries. These shared parts are color-coded. It makes sense to implement this common structure only once. With the builder pattern, we can put common steps, the default, into the parent class. This is another reason why the methods of the parent class were not declared abstract earlier. The implementation of the method buildLine2 of the address builder class now looks as follows. For most addresses, line 2 is house number, then street, except in Germany, where it's street, then house number. Only in the German formatting we have first the street and then the house number. Therefore, the construction of this line has been implemented in address builder. So the method buildLine2 in the classes US address builder, French address builder and GB address builder does not need to be overridden. The same logic applies to line 4. Most countries use the country as line 4. But English addresses use the zip code. So buildLine 4 also goes in address builder and is overridden in the English address builder. Line 1 is a little more complicated. First name comes before last name, but the title salutation changes. Please pause the video and think how you would do this. Write your idea in the comments. We decided to provide a default implementation in the parent class. In our solution, titles for masculine and feminine forms, title M and title F, are added to address builder set by the constructor of each child class. That's the reason why their visibility is protected. The method build line 1 of address builder then looks as follows. Because the title attributes are now accessed, the code is the same for all child classes. As an example, the constructor of the child class German address builder is shown. Here you can see the values for title M and title F are set. Now the class diagram looks like this. Build line 6 could be left out, but the example shows what's possible with a builder parent class. In the parent class you can leave methods empty to let child classes implement them if needed. For example, German, French and US addresses do not need lines 5 and 6. You can provide a default implementation for methods, letting child classes override if needed. In our example, build line 1, build line 2 and build line 4. And last but not least, make methods abstract if you want to force child classes to implement them. We didn't use this in our example. Looking at the diagram, you can see which builder child classes override each method, because their addresses have a different line order than the default. Now let's see how to generate all 4 addresses in the main program. First, we create the address data. Then we set up a container of the 4 address builder child classes. We use a loop to build each address with address director objects. Finally, we print the addresses to the console. Here you can see the result. You might improve this example with a factory to choose the right builder, but I leave this for an exercise. For completeness, I will show the code of each address builder class. Please pause the video if you want to study the code. The code shown here can be found in my Git repository SwegEd/builder. The link is in the video description. There are also examples for other programming languages in the repo. Now that we have learned all the steps, what does the builder pattern look like in general? In general, a client asks a director to build a product. This happens by calling the method buildProduct. The builder class has the methods to build each part of the product via build part 1, build part 2 and so on. Many common steps can go into the builder class, so this class is often not only an interface class. The concrete builder specializes these methods for each product. The concrete builder can also return the finished product. If you look closely, you see our example is a bit different from the classic pattern. In the general case, the concrete builder has a direct connection to the product. In our code, the parent class address builder has the connection to the address, our product, not just the child classes. That's because in our example only the string formatting is different. This shows patterns can and should be adapted to your needs. After watching my builder pattern example, it would be interesting for the community to know where you have already used the builder pattern. Please note these further use cases in the comments. This helps the community. The question that must be asked for all patterns is, when should you use the builder pattern? First, when you must build similar but slightly different objects, like the addresses in our example. When you need step-by-step construction, the steps can then be implemented individually and errors can be addressed very specifically. That also applies to the addresses. Or when you have to build objects in different formats, not just only formatted strings, but files, streams, and so on. And you can use it for any object with a complex construction process. Now here are the main pros and cons. On the pro side we have the children does not need to know how the object is built. Steps of construction are hidden from the client. Code is cleaner and easier to read. You can add new products easily by just making new builder subclasses. This upholds the open-close principle. We need only extend our code to create new products. We don't need to change code. Code is more maintainable. Specifics are handled by each builder subclass. And if a step fails, just redo that step, not everything. On the con side there are more classes which might feel complex. But putting all steps in one class would be harder to maintain. There is tight coupling between product builder and director. And like all patterns, don't use it when a simple solution is enough. By the way, the builder pattern is similar to abstract factory. I will cover that pattern in another video. There I'll also discuss the differences. What's going on now? Ah yes, the excavator. I almost forgot. Let's look at road construction. To lay cables or pipes, there are several steps that must be done, often in a specific order. The steps differ slightly depending on what's laid. First you choose the location. Then you dig. Sometimes you add walls for safety. You lay pipes or cables. Then you fill the pit, compact the earth, fix the surface and document the work. This is another example of the builder pattern. Many steps, sometimes similar, sometimes different, but always in a set order. In this video you saw how the builder pattern works, how to use it and what its pros and cons are. The road construction example shows that the pattern is not just for programming, but for many step-to-step processes. If you like the video, please give it a thumbs up. If you have questions, please write them in the comments. Thank you for watching. See you next time here in Software Engineering Education. Separate the construction of a complex object from its representation, so that the same representation First we need a data object to store the address fields. Usually first need if you compare them with formatting, looking at the diagram you can see which builder child class First, you choose the location. Thank you for watching. See you next time we're here in Software Engineering Education.